In this ShearMap application example, we will try to identify corrosion on a steel pipe under a composite racked repair. We've simulated corrosion on our sample by creating cavities in the pipe, which were then filled with plastilina before the composite wrap repair was applied. The wrapped repair consists of a strong two-way woven fiberglass cloth combined with an epoxy system and is about 5 mm thick. The steel pipe has a diameter of 73 mm with 5 mm wall thickness and is of a quality that is commonly used in oil and gas installations. This is, of course, intentional, as corrosion is a growing problem in the oil and gas industry, and as installations get older, the need for maintenance and repairs increases. Composite wrapped repairs work well, but sooner or later corrosion will start to appear under the wrapped repair again. And how can you detect that? Well, with the ShearMap, of course, we excite the pipe by clamping a piezo to the far end. In the field, this could be strapped on anywhere in the vicinity of the wrapped repair. We then look at some single frequency responses, first at 10 kHz where we see very little. At 20 kHz we can clearly see the larger scab, and at 30 kHz the two smaller scabs start to appear as well. At 40 kHz the separation between the two smaller scabs is much better, which is also the case at 50 kHz. At 60 kHz we see less at the two largest scabs, but the smallest one is still clear. At 70 kHz, all scabs are clearly visible, but at 80 and 90 kHz, the response starts to fade. When we run our patented damage detection scan, we get a very clear image of the underlying corrosion scabs very quickly. What you see here is happening in real time. No speed up or post-production is applied. Such scans should, of course, be taken periodically after the initial repair and combined with periodic follow-up inspection in order to detect reoccurring corrosion and monitor the extent of this until a new repair or a full replacement is required. The scabs we see here are about 1 by 1, 2 by 2, and 3 by 3 centimeters and just a few millimeters deep. If you are a member of the Hoist Consortium, you can also request the report from our tests on passive fire protection from them for further documentation of the ShearMap's capabilities. If you're curious about what more our instruments can do, please don't hesitate to get in touch.